So I want to take a look at some algebra questions with one variable. And you might be thinking, those sound rather easy. But the truth is that the hardest of these questions often stand between people getting a 700 and an 800. So these are questions that tend to make the difference for even top students. It's also true that these are questions that students scoring in the 500s can definitely get right, even the hardest of them. And of course, if you're scoring in the 500s, you're probably not getting, as of now, the hardest questions right. So these are questions that are very useful for everybody, and there's a couple easy methods we can use to make these questions kind of click for you. So let's jump in and try a few of these. All right, so we're looking at this question about our friend Hector. Okay, you'll notice first and foremost the answer choices. And you might say, well, shouldn't we start with the question? And my response would be no, let's start with the answer choices. You'll notice that B and C have a lot in common. I'm not telling you that one of those is definitely right, but I'm paying attention to those two very close answers because certainly there's got to be something about those answers that makes some sense. One more thing I'll mention just as I glance at this question is the relationship between the 5 hours, the hours of 3 and 8. Of course, there's a relationship there, right? So be thinking about those things. Also 5, 7, 12. Now, I'm not telling you should spend a bunch of time on test day looking at those little patterns. I'm just telling you should train yourself to be cognizant of those patterns because it can help you catch a mistake before it's too late. So let's jump into this question. We're going to read the last sentence first. That's right here. If the auger continues to remove corn at this rate, what is the total number of hours Hector will have been using the auger when 12,840 bushels of corn remain in the bin? All right, there's two words that I'm going to underline: total hours and remain. So in other words, it's not when 12,000 have been taken out of course, but when they remain, right? Okay, so now look, if we read a couple of these other sentences, and I'm not of the opinion on math questions that you have to read from the top down. Sometimes you can sort of jump in on different sentences. We have 2,400 bushels of corn when he began. And after 5 hours of using the auger, he's at 19,350. Now, you could do a precise calculation here, but you could also probably say that, okay, well, the difference between 24,000 and 19,350. Of course, you could go to your calculator, but you could also just say that's about 5,000. I know that it's not precisely 5,000. It's about 5,000, right? So 5 hours, about 5,000 have been removed. That means after like 10 hours, approximately 10,000 have been removed. And in 12 hours, approximately 12,000 have been removed, right? So these answers are looking much better than these answers. Now, you might say to yourself, why in the world would we do an approximation when we could just jump into a calculation? This is one of the most important things I can teach you about problem solving on the SAT and just generally. You should have a logical expectation for your answer before you do a calculation. It's not that your logical expectation will always be correct. It's that by creating logical expectations for yourself, you're likely to catch a mistake in calculation if that sort of thing happens, right? So if you have a logical expectation and you have a solid calculation, they should line up, right? And if they don't, that should give you some constructive pause, right? A constructive moment to say to yourself, I wonder which one of these things is correct. I can think about which one of these things might be correct. That can save the day, all right? So the exact amount that we get, I'll erase my approximate value here. The exact amount that we get, of course, is 4,650. That's in 5 hours. So once again, I'm going to use, I think, a bit of a estimation here. I could say something like this: 5 hours. Oops, I spelled hours wrong. 4,650. And then we want to know the X hours for which we've removed. What's the difference here? 11,000. Is that correct? Yeah, 11,160. right? Now, here's what I know for a fact. By the way, if you're asking, what is this number down here? This number is the amount that has been removed, right? So I've set up the hours and the amount removed as a ratio. The number of hours spent and the number of bushels removed is equivalent to our unknown number of hours in that relationship to the amount removed after that unknown amount of hours, right? Which is 24,000 minus 12,840. Now, let's estimate again. Should it be double? Well, if x were 10, we would expect twice this number. Twice this number, you don't have to know what it is exactly. You just have to know that it's less than 10,000. For that reason, when x is 10, this number will not be 11,000. It will be, under 10,000, right? Doubling 5 to get to 10. Doubling 4,650 would get you to less than 10,000. Okay, so x is bigger than 10. Here is my answer. Now, that explanation may not be the way that you would normally do the question. That's cool. I'm glad that you have multiple ways of thinking about this question. I'm glad if you feel like you could have set up a really basic equation and solved. That's perfectly great. The problem is if you set up an equation, you're likely to have confidence about that equation when it is possible that you've set up the wrong equation, right? So that's the way I would suggest doing it. If you set up an equation, of course, you could get a slope of bushels per hour, right? And you can set your y-intercept to 24,000. So it would be something like this. Y equals mx plus b. And then you know that this b is 24,000. That's our starting point. And your slope would be the difference in these amounts. So the slope would be the change in y, where y is bushels of corn and x is hours. The change in y would be, like we said, 4,650 divided by the time, 5 hours. Now you could reduce that, of course. Here's your equation, if you built it correctly. Y is the number of bushels after x hours, right? So you could put this number in here, 12,840. You could reduce this calculation, which would be 930x plus 2,000. It's negative, by the way. It should be a negative value. 24,000. There's your actual equation. I just don't recommend doing that. I recommend using logic and reasoning in advance of a calculation, and I don't recommend building equations. I'll tell you more about that as time goes on. Here we are talking about our friend Alan. Okay. So this is a question I'm telling you that almost all of my students have gotten wrong, and I'm talking every year I have someone who gets a perfect score, and this is a question that every single one of them, maybe one or two people will call me on that, but most folks have gotten this question wrong, all right? So let's point out the challenge by looking at the answer choices first. It's either 5 or 95, and it's either 25 over 4 or 4 over 25. Those differences seem obvious. 95 and 5 are hugely different values, and 25/4 and 4/25, of course, are very, very different numbers. But reciprocals suggest a certain kind of mistake. Should I multiply or divide? Right? Those are the kind of questions that are theoretical. And I watch people struggle with this question typically because they are not using real values to do the math. Okay? So if you have single variable in the answer choices, or even two variables in the answer choices, I highly recommend practicing picking values, right? And you can't just pick any arbitrary value for m. If we read this last sentence, we see that gasoline costs $4 per gallon. Which equation can Alan use to determine how many fewer miles he should drive each week? If you want to try the question on your own, by all means, pause this video and try the question on your own. Continuing here, let's take a look at what we know. A huge part of problem solving is telling yourself, what do I know And what do I need to know? Well, here's what I know. $4 per gallon. Right? That's the cost per gallon of gas. And then we know that this dude drives 100 miles a week. And we also know that his car gets, I'll put this up here with the gas information. We know that he gets 25 miles per gallon. Okay. Dude wants to save $5. $5 savings, like fewer miles. Let's underline this word fewer. I'm just going to say question mark miles fewer. So what I've just done is extract information from the question. So I see all the things that I know. And it doesn't have to be in a gorgeous way. It has to be in a way where I can see them and process this information. So look, this information is key. We want to say, well, how does he save $5? Well, look, let's start with saving $4. How does he save $4? Well, he should drive 25 fewer miles to save $4. Right? So how about $5? I know you could set up a ratio here. You could say $4 goes to 25 miles and $5 goes to X miles. And you could certainly solve that. You could also just say around 30, right? X is approximately 30. All right, approximately 30. It's actually 31.25 if you do the calculation and solve for X. But the number that we're going to go with is 30. That's a value of M, right? I wrote X here, forgive me. M is the miles. That's a value of 30. So we go to these equations. 30 has to work as a value in this equation. So 25 over 4, what is that, approximately 6-ish? 6.25, I'll say 6-ish, times 30-ish, nowhere close to 95. Same thing here, the exact same math, 6-ish times 30-ish, right? 25 fourths is 6.25 times our M value of around 30. No. Well, if 25 fourths is 6-ish, then 4 25ths is 1 over 6-ish times 30. And of course, that's not equal to 95. It is equal to 5. Okay? So am I asking you to be imprecise at all times on this test? Of course not. But I am telling you that on math questions with a single variable, you can solve these questions with real values oftentimes. One last little bit of information. I do want you to be able to do the question with, a more, let's say, standard approach. If you recognize this question to be what it is, I haven't seen anybody really do this on practice tests, but 25 is miles per means divide, gallon. And I'm analyzing answer choice A here. 4 is dollars per gallon. Okay. And then M is miles. You could do a dimensional analysis here. First of all, you say, well, 95. What is that even? That's a conflation of the miles and the dollars. So no to the 95s. The 5, however, is dollars, right? So here is equation B, and miles per gallon divided by dollars per gallon. There's two ways of thinking about this. I could write M over G, and then I could multiply by this reciprocal, which is G over dollars times miles. The G's cancel, but we get miles squared per dollar, which is a strange unit. That's wrong. And if you look at D, it's the inverse of this first, is the reciprocal, this first number. So dollars per gallon divided by miles per gallon. I'll use this opportunity to show you the other way of thinking about this. If you have the same denominators in fractions that are divided, the denominators cancel. It's the same thing as what we did up here, just in a different explanation. Dollars per mile times miles. Now the miles cancel, and you get dollars. That's a dimensional or a unit analysis approach, and that's answer choice D. So you can see that that approach is extraordinarily specialized, whereas the approach we used originally is something that we're going to see repeated on any number of question types. So that's why I highly recommend using real values as opposed to doing this approach where you use dimensional analysis. Let's move on to the next one. Okay, so this question says, how many solutions does the equation have? And this is the classic. They're going to ask you this question over and over again. There's an algebraic approach and there's a graphic approach. I prefer the graphic approach because I'm kind of punk rock. Whatever they show me, if they show me algebra, I'm going to think I'm going to think, graphs. And if they show me graphs, I'm going to think algebra, oftentimes. Okay, so first thing is let's distribute this 10. We're going to get 150x minus 90. And you're like, hey, why'd you add that y in there? Because I like to think about each side of this as its own equation. This other equation here, after distributing the 15, let's rearrange these two. Negative 15 times negative 10x is positive 150x. And then negative 15 times 6 is negative 90. Okay, you can see we have the exact same thing on both sides of our equation. The reason I said graphic explanation is like if you think about these as lines, of course they're the same lines, right? We would graph them. I'm not saying that you should make a nice graph. I'm just saying I think about these graphically. Let's call this negative 90, and we've got a really steep slope, right? Well, the other line is exactly the same slope, exactly the same intercept, so we have infinitely many intersection points. So every time you see discussion of solutions, I want you to think intersection points. That's the key way that you can think about these questions. So let's move on. You might have thought when we left the last question behind, why are we moving on so quickly? Jeremy usually gives, really detailed or thorough or long-winded explanations. Why do we move on so quickly to this next one? And the reason is because it's much the same as the last one. Right? So we have this idea of no solution. And you might be thinking, how is this the same? The last one was asking the number of solutions. Now we're asking for the value. Whenever we're talking about solutions and we have no exponents anywhere in our equation, we're going to use the exact same approach over and over again. So I'm thinking sort of about slopes here and intercepts. I'm thinking graphically. Let's distribute the 3kx plus 39. I'm going to write that as y equals, and I'll write another one as y equals 48/17 x plus 36. Now look, unlike the last question, we have different looking equations. We certainly have different intercepts, and our slopes look different. So if we have different intercepts, think about that graphically. And again, you don't have to make a great graph. Let's just call this 36. And let's call this 39. Okay, so I don't have to know what this slope is precisely. It's some sort of a positive slope. It kind of looks like maybe like this. Again, it doesn't have to be a perfect representation. Well, what kind of line would never cross this line? Of course, a parallel line, right? So here is a parallel line. What would a parallel line have? It would have equivalent slopes, okay? So all of that happens really quickly for me when I've done these questions a number of times. I now know that I'm looking for equivalent slopes as soon as I see the discussion of no solutions in a linear equation. So I'm looking at 48/17 and 3k. Those two things have to be equal. And that's an easy thing to solve, of course. 48/17 equals 3k. Now I'm going to divide both sides by 3. So 48 divided by 17 times 3 equals k. Now that's calculator work, but I will do it out for you. That's 48/51. And those are both multiples of at least 3, right? So if I divide 48 by 3, I get 16. It's probably going to be able to reduce this again. If 51 divided by 3 is that 17? So I guess I can't reduce it any further. So 16/17 is the answer to this question, right? So this idea of no solution, it comes up again and again. And my goal for you as a test taker is that you know how to do this question instantly and you drop into this method. I will say one other thing. Of course, you could solve this algebraically. Of course you could. 3kx plus 39 equals 48/17. Sorry for my bad handwriting. 48/17 x plus 36. Okay, let's isolate x and do all those things we're used to doing. First, we'll subtract 36 from both sides. Having done so, we'll get 3kx plus 3 equals 48/17 x. Okay, so now let's probably group the x's together. 3 equals 48/17 x minus 3kx. Now, in my experience, this is where my students get a little bit lost. Okay, here's what we want to do here. We want to factor out x. And then we get 48/17 minus 3k. And here's the trick. There is no value of x which will solve this equation if our set of parentheses, 48/17 minus 3k equals 0. If that equals 0, 0 times x will never equal 3. Right? So there we have some final calculations to do. 48/17 minus 3k equals 0. Of course, that's the same thing as 48/17 equals 3k, having added 3k to both sides. And now divide, you'll start to see something very similar here. This is 48/51, which I now know, of course, is just 16/17 because I'm so good at reducing. Really, because I've already done it. Okay, so that approach, as you can see, is perfectly valid, and that may be the way that you were inclined to do it at first. But I think we could both admit that recognizing no solutions as a situation in which you have two equations set equal to each other and that those slopes must be the same is probably a faster way to drop into 3k equals 48/17, right? So that's what I recommend here. You'll notice both of the last couple questions are about the slopes being equivalent. If you talk about no solution, or if you talk about infinite solutions, you're talking about equivalent slopes in these linear systems or in a linear equation with two sides like that. All right, here's another one. We're talking about a certain product. How vague? A certain product. All right, so let's look at these equations. Let's start there and recognize the 0.2 and the 0.8. That's a big thing because, of course, 80%, let's say you take 80% off. Well, that means you keep 20%. And vice versa, of course. If you take 20% off, you keep 80%, right? So this is the kind of thing that you can look out for on tests all the time. Anytime they bring up 20%, they bring up 80%. Don't just immediately cross those off without thinking further about it. It's really important that you think carefully about what that might mean. All right? So let's start this question off. We'll read the last sentence first. If the sales price of the product is $100, which of the following equations gives the number of units U of the product the company sold to make a profit of $6,840? Okay, so we are looking for the number of units U. Well, there's two ways of approaching this. You could, of course, just analyze these pieces, but I would invite you to roll up your sleeves and think about this in terms of real numbers so that you don't fall into a trap, okay? So it costs $65 to make it. So cost $65. And then the product is sold by a salesperson who earns a 20% commission on the sales. Okay, so another cost, you could say, is, well, we don't know the dollar amount, but we could say that it is 20% of a price. And they tell us down here, I remember from our last sentence, 20% of $100. So the cost is also then equal to $20. Okay, so here are the costs. Total cost is equal to $85. And that means the profit, which they explain here, is the sales minus the combined cost. The profit is equal to $100, the sale price, minus the $85, which of course is $15. right? Okay, so we know that. We know what the profit is. Now, what I would invite you to do is try to figure out something like how much money does it cost to make that profit, right? And again, you could sort of estimate here to a certain extent, right? Of course, you could just plug it into your calculator, but give yourself an expectation. I'll do that up here. Let's say I sell 100 units. That's going to be worth $15 times 100. Okay, I want to make much more money than that. Let's say I can see that 400 units, multiplying that by 4 will get me to $6,000, right? And then I want to make another $840. Okay, well, again, I could easily say 40 units gets me $600, right? So that's 6,600. I still want to make another 240. So a little bit more than that. I could say another 10 units, for instance, would get me another $150. And if I add up, not that amount, but these amounts here, I get 6,750. Now, that's not exactly what I want to make. I want to make a little bit more than that. But I can say then, for instance, that this number of units should not work. It's really close, though. So that's 450 units. That is worth a dollar amount of 6,750. Now, that's not exactly right, but now I can probably estimate what's going on here because all of this math looks like a lot, but it quickly becomes obvious what is and is not true. So now I'll look at my answer choices. And, there's no reason to presume one thing over the other here, except, you could interpret this and say we're subtracting 20% or we're keeping 80%. So the idea of subtracting 80% doesn't look really good, and the idea of keeping 20% doesn't look really good. That could at least cut down on some of my my plugging in here. And this equation is probably easier to solve. 0.8 times 100 is just 80 minus 65 times. We know that this value is close, 450. Obviously that's going to be a negative number, right? So A looks really good here. Maybe I'll finish out with an evaluation of my equation. $100 times 0.8 gives me $80. $80 minus $65 gives me $15. $15 times U should give me the total, right? My $15 profit times the number of units that I sell should equal my total profit. Right? So I'm not telling you that you shouldn't start with maybe how I finished. Maybe you should start with your theory of the case. I like answer choice A, or maybe you misinterpret the equations and you like a different answer choice. I'm telling you that you should take your theory and you should take real values and use them together. That is the way that you maximize your score on this test. Okay, cool. Let's keep moving here and try a new one. All right, so here we have, in the given equation, k and n are constants, and n is greater than 1. The equation has, here we are again, no solution. What's the value of k? You should be ready for these ones now. We're going to distribute 2kx minus, be careful about distribution. Everyone's going to mess that up. Negative 28/15 x minus 36/19. These two pieces right here must be equivalent if there's no solution. Now, some people will say, well, what about n? Well, the thing is, there may be multiple. I mean, for one thing, 2n cannot be 36/19. That's true. Because if those were equal, if n is, essentially half of 36/19, then we would have to worry about a second fact, not just what's true about k, but what's true about n. But notice this piece right here, n is greater than 1. Well, just for a little examination here, let's set this negative 2n equal to negative 36/19. You may already see what I'm seeing here. If we divide by negative 2, n is going to equal negative 36/19 times, negative 2 over 1, or negative 2. Now, what is that going to equal? Negative, or let's say positive 36 over positive 38, which is less than 1. So they've essentially controlled for that fact when they wrote n is greater than 1. And I didn't even worry about that fact as a test taker because I've seen enough of these questions to know it's impossible for them to frame a question, or at least it has been impossible to this point, as far as I can tell, for them to frame a question in such a way that that y-intercept matters. Okay? So as such, I only focused on the slopes of both sides. I know they're not the slopes, but as you heard me explain on a different question, I think of the coefficient of x here and the coefficient of x here as slopes of two distinct lines. The left side is a line and the right side is a line. Okay, so 2k must equal negative 28/15. Why? Because if we want no solutions, we want parallel lines. Right? This line on the left and this line on the right must have the same slopes in order to have parallel lines. And we'll divide both sides by 2, and we'll get negative 28/15 times 2, which of course is negative 28/30, which reduces to negative 14/15. All right, so there's the value of k. You can see this pattern over and over again with these questions. Let's take a look at this question. It's slightly different than the other ones because here they ask for the solution. They don't ask for a value that gives us no solution. Right? So you could do two things here. You could just distribute and solve for t, nothing wrong with that, or you could use u substitution. So we could say u equals t plus 3, and our equation gets much simpler. 5u minus 7u equals 38. Negative 2u equals 38. U equals 38 over negative 2. And 38 over negative 2 is negative 19. That's a value of u I could then plug in up here. So I could say u, negative 19, equals t plus 3. I could subtract t from both, or 3 from both sides. And that would give me negative 22 equals t. So slightly different question. You could, of course, just distribute 5t plus 15 minus 7t minus 21. Almost as good, but worth noting the u substitution because there are some questions in which that will be by far the most optimal way of doing the question. And I would like you to see that now on maybe a question in which you have some flexibility. So we'll move on to the next one. Okay, the Townsend Realty Group. All right, so let's read the last sentence first. We see numbers for answers. They're too complicated for me to really notice much of a pattern except that A is twice the size of D. So the last sentence first. The Townsend, which of the following approximates the original price? So this represents original. Okay, so the Townsend Group received a 40% discount off the original with an additional 20% off the discounted price. Now, that's not the same thing as saying a 40% discount and a 20% discount. It's a 40% discount off of one thing. Once you've taken that discount, you get a smaller number, and then you have 20% off of what remains. So you could build an equation here. I'd highly recommend using the numbers here. Look, 40% and 20%, it's like, around half off, right? It's not exactly 60% off. If you think it is, I'll show you why that's wrong in a little bit. But it's about half off. So if Glenview was purchased for $140, then the original price is about double that, like $280. So I'll go to the closest one of those, $291.7. Let's multiply that by 0.6. Why? Because 0.6 is 60%. If you're not sure about that, think about this. 60 over 100. 60% is 60. Per means divide. 100 is cent. So 60 over 100 is 0.6. If we keep 60%, we've gotten rid of or gotten a discount of 40%. You would take that, and then you would, whatever that value is, let me actually just do that calculation here. I'm going to grab my calculator. So, 291,700 times point, let me do that again, 291,700 times 0.6. Okay, so 175,000. Then you would take that value and you would multiply it by 0.8 for the same reasons as 0.6. That is, you keep 80%, you remove 20%. So let me see if that works. It looks pretty good. 0.8. There we have it. It's really close. Now, if it said exactly, I would know I was wrong, but this says best approximates. So this looks great. If you were to build an equation, you would say the original, call it x equals, not equals. You would say the original price times 0.6 times 0.8 equals the purchase price, 140,000. And you could solve for x here. It's just that most people struggle to set up that equation, right? So I think it's a huge advantage to just do it with the numbers that are given on the page. Look, if this were too small, we would know without doing any more math that A was the right answer. And if this were too big, we could probably make a choice between C and D. And if not, we could try out C. If C was still too small, then we would know. If C was still too big, we would know that the answer is D. Right? So that's, another approach to this question. All right. Let's try another one of these. Each side of a 30-sided polygon has one of 3 lengths. They want to know which of the following must be true of n. Okay, the number of sides with length 8 is 5 times the number of sides n with length 3. There are 6 sides with length 4. Okay. I wouldn't even build an equation. 30 sides. Subtract the 6. You're going to have 24 sides remaining. 24 sides. You have a lot of 8 centimeter sides, and it's 5 times as many as the 3 centimeter sides. All right, well, let's just try out some values here. Like I said, if n is 1, you're only going to have 5 sides that are 8 centimeters. We need to get 24. Let's make n significantly bigger. Let's make n, 3, or I guess 4. 4 sounds like the right number. I just guessed that. But if n equals 4, then 5n, which is the number of sides with 8 centimeters, is 20. There we have it. So what equation works for that? Well, n is 4. Let's just go back and see which one is accurate. 5n plus 6 is 24. 20 plus 6. No, this is 24 plus 6. Now, this equation did not at first jump off the page to me. But the reason I was able to confirm that it was the right answer is because I grounded my thinking in real values. Now it makes sense to me. If you think about 8 centimeter sides plus 3 centimeter sides plus 4 centimeter sides, the thing is we're not multiplying 8, 3, and 4 by anything. These are just the sides of this length. This is 5n. This is n, right? 5 times the number of sides that are 3. So if this is n, this is 5n, and this is 6. So this equation simplifies to 6n plus 6 equals 30. Oftentimes, the algebra makes a lot of sense at the end, which is why I recommend using real values to start as opposed to using real values to end. But you could use both. I mean, if you did an equation, you would just want to make sure, confirm that with the real values, 30 sides, that the equation actually made sense. Right? So that was an interesting question. Okay, so here they want to know which the equation has no solutions. We've seen plenty of these before, right? Here's what we need. It's set up a little differently than the other ones we've seen. If you like, you could make this one look like the ones we've seen before. Add 3x to both sides. In order to have no solutions, we could now think about these two as separate equations, and 21p is the slope of the first equation, y equals 21px, and then the second equation is y equals 3x plus 84. Right? So in that case, 21p is 3, and you could solve that. 21p equals 3 means p is 3 over 21, and that reduces, of course, to 1/7. That's the way we've looked at them before. The SAT is always trying to come up with new versions of the same idea so that if you're too inflexible, you might be confounded by the calculation. So here's the other way of thinking about this. If P makes it so, think about, we did this on a different one. Think of factoring an X out. We could say -3 plus 21P times X equals 84. Well, if this thing in parentheses is 0, there is no value of X that will get us to 84, right? 0 times any value of X will not equal 84. So now we're doing the exact same thing we saw before. Negative 3 plus 21p equals 0. By adding 3, you get right back to where we were. 21p equals 3. P is 3/21, so 1/7, right? The no solution thing showing itself in a bunch of different variances. Okay, x plus 6 equals x plus 6 over 13. The value of x plus 6 is between which of the following pairs? That's really interesting because they don't ask us what does x plus 6 equal. They ask us where is it relative to, a set of values, right? A range of values. That's a really interesting question. And I just want to highlight that, this is a eureka mistake question, which is to say x plus 6 is a really easy way to get confused between what you're solving for. Are you solving for x or this other thing? So I'm going to flag a mistake. I think if we're not looking for x, but instead x plus 6, I think the lowest number is almost certainly wrong. It's almost certainly wrong that if maybe x is negative 6, then the answer would have to be that value plus 6 or 0. So this is I don't know that it's wrong, but I'm almost certain. And if you guard against mistakes logically, you're less likely to make them when you're doing a calculation. Okay? So let's jump in to the actual calculation. It would be a cross multiplication calculation. 13 times x plus 6, right, equals 3 times x plus 6. Okay, so we could distribute and solve. 13x plus 78 equals 3x plus 18. That subtract 3x from both sides, we'll get 10x. Subtract 78 from both sides, we'll get negative 60. X is equal to negative 6. Oh my goodness. I promise you I didn't know the answer when I started. Look, the test is really predictable, okay? And so you saw me ahead of time kind of guessing the game here. In fact, looking back on this, of course, this will work. The same numerator, you may have seen this pattern if you're really smart. X plus 6 over 3 equals, I'll write it here, equals x plus 6 over 13. Well, when is that true? How about when these things are both 0? That's what they were hoping you would notice. Light dawns on Marblehead, as they say on the North Shore of Massachusetts. Can I get these last two questions done for you really quickly? I wonder if I can. Let's see. So, look, we want no solutions. This is just like other ones we've seen. Distribute 9x plus 5 equals ax plus ab. Well, what must be true? In order to have no solutions, think about these as the same slope, as I've been saying before. I know you can think about it algebraically too. I advocate this method. A must equal 9. Cross off anything that doesn't include a equals 9. Well, that's the first one. It just allows us to cross this off. Okay, so now look, in order to have no solutions, we have to have different y-intercepts, right? We can't have the same y-intercept or else there'd be a solution, which would be at the y-intercept or when x equals 0. So 9x plus 5, I'll just kind of give us so I know that's not a great version of 9x plus 5, but just go with me. That's 9x plus 5. Well, if we're going to have no solutions and a is 9, we're going to have parallel slopes. That means AB cannot equal 5, right? Does B have to equal 5? Definitely not. And we should examine that a little bit more closely. If 5 cannot equal AB, and we know A is 9, 5 cannot equal 9B. Divide both sides by 9. 5 over 9 cannot equal B. So what must be true? This one must be true as well as Roman numeral 1, 1, and 3 only. All right, let's see if I can crank out this last question for you. Yes. So we see the variable in one equation. That makes me drop in immediately to picking a value for x. Pause and read the question if you like, but x is the number of stations set up for experiment A. There are 5 total stations for either A or B. Let's make x 4. X equals 4. That means you have 4 stations with 6 teaspoons of salt for 24 teaspoons of salt. And then you have 1 station that needs 4 teaspoons of salt. So when x is 4, I need to get 28. Plug that back in. This is 20. This is 40. This is 28. 2 times 4 plus 20. This one would be, of course, much bigger. This would be 40 plus 20. So no. Okay. I hope that helps you. We're using real values. We're using logic. We're using reasoning. Stay tuned. A lot more to come. Thanks.